Learning target algebra numero dos. It's all about operating and solving with quadratics. What's a quadratic? It's basically a equation that has a max exponent of x to the second. The normal is like ax squared plus bx plus c. That's the standard form, the basic all addition and stuff like this, all numbers in front. But actually, there's like a level 1 version, which is the more common version that you'll deal with, is if the front number is actually 1, so we don't even write it. So x squared plus bx plus c. So notice no a here. These are much easier and they're much more frequent. But before we can even go down that rabbit hole, I gotta talk about this guy here. Okay, this is something I do every single year with my Algebra 1 kids. It's just my Mr. Lang spin on how to think about where this stuff comes from, because too often y'all forget about the numbers, right? We just forget about what are we actually doing here? Are we just memorizing rules? Are we actually doing mathematical numbers? So taking a look-see at this one, I think everyone in the room knows that 5 times 6 is 30. Yeah, it is. But then I have this weird thing, but what if x equaled 1? There's no x in this problem, so I'll get back to that. But if you look at this for a second, like 5 times 6 equals 30, right? This is all of 5, the whole number times 6, that whole number, all of it, right? You're not like multiplying just the 4, like if you imagine 5 as 4 plus 1, like you wouldn't forget the 1 and just do 4 times 6. That would be 24, and that would be 4 6s, not 5 6s. You would literally skip 1. You need to do all of that 5, all of it, times all of that 6. You can't just miss parts of it, right? Well, going back to this but x equals 1 thing, think about it for a second. If x is 1 and we have 5 times 6, this 4 plus 1 idea, isn't this the same thing? Isn't 5 the same as x plus 4? Right? Because we established x is 1. I told you x is 1 to begin with. So isn't 1 plus 4 together, this whole chunk, the same as 5? Well, therefore, what would 6 be? Right? So that would be x 1 plus 5. Right? Okay. So I have 5 times 6 still equals 30. You with me? Okay. So this problem, again, this is 5. Literally, I just took it and put it right here, right? 1 plus 4 is 5. I took the 6, put it right here. 1 plus 5 is 6. 5 times 6 is 30, right? That's 5, that's 6, that's 30. Okay, so the moral of the story is here is you wouldn't just multiply just the 4 times this stuff, right? You wouldn't do just this one piece times that whole thing, or you wouldn't do like just this 5 times those 2. Like you'd have to multiply the entire 5 times the entire 6 to get your answer. So it's kind of like you have to do all of 5 times all of 6. You have to do all of x plus 4 times all of x plus 5. Well, think about this. I have 2 items times 2 items. Shouldn't I end up with 4 items, right? I have to do the x times both, and I have to do the 4 times both. I can't just pick and choose. I got to do the entire thing times the entire thing. So what we do is we kind of draw these lines, right? We do x times x and x times 5. Well, x times x is x squared. X times 5, can't do it, so it's just 5 times x. We just write 5x. Okay, last but not least, positive 4, we have to multiply that by both. 4 times the x and 4 times the 5. We can't just not do the 4 times everything. So we'd end up with 4x and 4 times 5 is 20. So all 4 of these pieces are a result of just multiplying this. It's called a binomial because there's 2 items. Binomial times a binomial, and I get 4 things, 4 pieces. But what do we notice right here is that the middle 2 are going to be like terms. I'm going to be able to combine those. They're similar terms. We can't combine the x squared, don't have the same exponent, can't add those x's. And I think everything was positive. Well, I know you've heard this word before, F-O-I-L. FOIL is just an acronym to help you remember that there's 4 pieces. The first times the first, the outside times the outside, the inside times the inside, and the last one times the last one. And that's always the numbers. Hashtag L, last, the numbers 4 times 5. We always end with those. So that's just 2 numbers multiplied. Well, sure enough, check it out, my friends. Let's plug that 1 back in. What is 1 squared? 1 times 1? 1. What's 1 times 5? 5. What's 1 times 4? 4. And then, oh, that's just 20. 1 plus 5 is 6. Plus 4 is 10. Plus 20 equals 30. Boom. Boom. Yeah, of course it still does. Because I did the 5 times 6, but this was 5 and this was 6. It was just x was 1 in the problem, right? If I plug my 1 in here, 1 plus 4 is 5. Plug my 1 in for this x, 1 plus 5 is 6. It's the same problem. It's 5 times 6 is 30. It's just when we use x in both of those and we separate them, we create a little bit of chaos. We create these extra pieces here. So moral of the story is the simplified answer, I do have to combine those like terms. So it would be x squared plus 9x plus 20. That would be considered the normal answer there for simplifying x plus 4 times x plus 5. Okay, and then this is usually where people notice the patterns, okay, of, we know it came from one of these things, and we know 20 was 4 times 5, and 9, so this is like the 4 plus the 5, and this was like 4 times the 5. So people start to notice that pattern and can get a little faster at it, right? So if you had a FOIL problem like this, that was like, let's just make one up, like x minus 3 times x plus 6, you know, just made it up right now. So I would do the x times both and the negative 3 times both. But we notice the pattern. We know x squared times x times x squared is first. We actually know the end for sure. Negative 3 times 6 would be negative 18 at the end. Well, so it multiplies at the end, but they added together or combined in the middle. So if I think positive 6x, negative 3x, I can do that in my head. 6 and negative 3x, 6 minus 3x would leave me a positive 3x in the middle. Okay, so we can kind of skip that combining the center. If we just think about, okay, I'm combining the O and I of FOIL, it'll just be the negative 3x and the positive 6x would give me the 3x there, okay? So that is forward. And then what mathematicians sat here with these kind of problems, they were like, if this is called multiplying binomials and then I can get these answers here, I wonder if I could work backwards from this. Okay, so that will be in part 2 of learning target A number 2, algebra number 2. Again, algebra, super important. See you on the next one.